Hello and welcome to another one of these ADD videos. Today we're going to be looking at this example here of solving this first order differential equation. So right off the bat you should be able to recognize that there's a ax plus by pattern happening here. So that's probably the substitution that we're going to be doing there. So it's going to be 2 is your a and 3 is your b. So in that type of problem, we're going to first solve this expression for dy dx. Then we're going to make the substitution. Then we're going to derive implicitly this expression with respect to x. After that, we substitute. And you should be left with a separable differential equation that you can integrate. So let's see it in action. So there's the problem. In order to solve for dy dx, we first need to get these terms over. They're added, subtracted by doing the opposite. Then after that, we get that. Cancel on the left side. Divide by the coefficient of the dy dx. Everything that's not dy dx. Do it on both sides. Then you'll end up with that expression. So now we can do the substitution. So we go off to the side, and there's your substitution, and find your dz dx. All right. So we did step 2. There's your substitution. Here, when we derive with respect to x, derivative of z is 1 times derivative of z with respect to x. They don't cancel. Derivative of 2x is 2, and derivative of x with respect to x does cancel. All right. Derivative of y with respect to x does not cancel. So only one that doesn't get a d whatever dx is the x derivatives. So here we can now solve for dy dx by subtracting the 2 over, dividing by 3 everywhere, and then we can plug and chug further. So if I plug in what dy dx equals and what z equals, I come up with this equation. And then I need to simplify that a little bit. Add 2/3 on both sides, they cancel, and you're left with that. Well, here we need to now get the z's on one side and the x's on the other, because we now have a separable differential equation. So we multiply by the reciprocals there, and when we multiply by the reciprocals on this side, it cancels. On this side you get 1 over tangent, which is cotangent. And then we need to get the dx on both sides, so we multiply dx. Cancels on this side, leaves you a dx on the right side. And now that it's all z's on one side and all x's on the other, we're ready to integrate. So we integrate, and the left side integral becomes negative cosecant squared, and the integral of dx is x plus c. Now, a final step would be to plug back in your original variable. So instead of z, we plug in that. I'm okay with an implicit solution. You don't have to solve for y explicitly in all of these. Unless it says explicitly solve for it, then do so. But I didn't say it, and I just wanted the general solution plus c. So this is it. All right. Recap. We should recognize ax plus by. If you do enough of these problems, they'll start to pop out at you as far as what method to use. But if you just are cramming the night before the quiz, it's not going to help too much. Here, I mean, it'll help a little bit, I guess, but solve for dy dx, bring everything to the other side, divide by the coefficient and the cosine term. Sine over cosine is tangent, those cancel. Let z equal that, derive with respect to x, then we solve for dy dx, plug in what dy dx equals, and then plug in your z, simplify, integrate. That's your answer. All right, I hope I've clarified things enough for you to try some of these on your own. You'll see they're not as bad as you probably thought. It just seems a little overwhelming because it's new. As always, practice, practice, practice. Thanks for watching. Have a great day.